All right, so I'm here to talk today about the product rule in calculus. So if you've got a function which can be broken into two unique parts that are being multiplied, right? So f of x times g of x, the derivative of that product will be the derivative of f of x times g of x plus f of x times the derivative of g of x. That is really complicated. I can't remember it. I remember it like this: f prime g plus fg prime. Okay? Where the first function is f and the second function is g. Okay? So what I want to do is show you a few examples of how this works. And the first example I always show one of my classes is I show them a problem that we could do without the product rule to prove that it works. Okay? So I'm going to take a particular function here, and we're going to say take the derivative of 3x times x squared plus 2x minus 4. Okay? Now, with the product rule, the way we would do this is this would be f, and this would be g. And our derivative will be f prime g plus f g prime. So the derivative of the first times the second plus the first times the derivative of the second. Okay? So f prime is 3. G is literally just copying that function. So x squared plus 2x minus 4 plus f is copying that function, 3x, times g prime, which is the derivative of this part. Okay? Well, the derivative of x squared is 2x, and the derivative of 2x is 2, and the derivative of constant is 0. So we stop. Okay? Now we have to combine like terms. Okay? So to do that, we're going to distribute here, and we're going to distribute here. So if I distribute here, I'm going to get 3x squared plus 6x, keep breaking my pencil lid today, plus 6x minus 12. And then if I distribute here, right, 3 and 2 makes 6x squared, and that's going to be plus 6x. Now, combine like terms, we'll get our final answer. So 3x squared and 6x squared makes 9x squared, right? Scoot this up so you can actually see it. And then 6x and 6x makes 12x and then minus 12. Okay? And that's our final answer. Now, what if I did this without the product rule? Okay? What I mean is go ahead and multiply these first and then just use the polynomial rule. So if I multiply those first, which I'm allowed to do, 3x times x squared is 3x cubed, and 3x times 2x is 6x squared, and 3x times negative 4 is negative 12x. Now, use the polynomial rule and take the derivative of these three terms. Well, here you're going to say 3 times 3 is 9, and reduce that by power of 1. So you get 9x squared. Here you're going to say 6 times 2 is 12. Reduce that by a power of 1. So you get plus 12x. And for some reason, some students have the most trouble with this one, but I'm going to walk you through it. Remember, that's a 1. So you're going to say this guy times 1. All right, well, negative 12 times 1 is negative 12. And you're going to reduce this by a power of 1, which is x to the 0. And somewhere off to the side here, I'm just going to remind you to remember that x to the 0 is equal to 1. Okay, x to the 0 is equal to 1. So you get negative 12 times 1, which just gives us negative 12. Okay, so we get the same answer. As a matter of fact, if you are given this problem, you should not use the product rule because it is easier to multiply these than it is to simplify that. Okay, but I like to do my first example with 1 so you can see we get the same answer. The product rule is typically used on things we cannot multiply. So let me give you a good example of that. If I ask you to find d dx of square root of x times x cubed minus 7x. Okay? So, because of this square root, this is not something you could readily distribute to those guys. And so we would use the product rule. Okay? And whenever we use the product rule, we always want to go in and label our two functions, right? So this is our first function, f. And this is our second function, g. And I always write my rule. Okay? So my rule is this derivative is going to be equal to f prime g plus f g prime. Okay? And you can write multiplication in there if you choose, or you can just write them next to each other and know that it implies multiplication. That's a personal preference. But long story short, guys, you got to make sure that you know your two functions and you know you can find the derivative of those two functions. So with that said, my pencil ran out of lead while I was talking. That's my luck. So let's go ahead and do this. So f prime, right? So the derivative of square root of x. Now, if you've never seen this, I'm going to come off to the side and do it as kind of what I like to call side work in my classes, okay? But this is one you should memorize because you run across it so much, okay? So I'm going to show you how to get this. So I'm going to rewrite this as x to the 1/2, x to the 1/2 power. And I'm going to take the derivative of that, okay? Take the derivative of that. And the way we do that is we multiply the power by the coefficient, so we get 1/2, and then we subtract 1, which is going to give us x to the negative 1/2. Well, that is going to be square root of x moved to the bottom. And so that's going to give me 1 over 2 root x. Okay, 1 over 2 root x. And I've just got it memorized. Whenever you take the derivative of square root of x, it's 1 over 2 root x. Okay, 1 over 2 root x. So, for f prime, I'm literally going to write 1 over 2 root x times, and then for g, I'm just going to copy. Right? So I get x cubed minus 7x. Right? And then plus, and for f, I'm going to write square root of x times, and then g prime, well, you got a 1 here. 3 times 1 is 3, right? And then reduce that exponent by 1. And then negative 7x, that'll just be negative 7. It'll be the derivative of g. And then we try to combine these any way that we can. Okay, we try to combine these any way that we can. Unfortunately, there's really no way to combine these, and so that would be our final answer. Okay, bam, product rule. Okay, let me give you a different one. One that I think is a little more kind of with how you would use this. Okay, so let's say we've got 3x to the 5th plus 7x squared times x to the 4th minus 3x squared plus 11. Okay? And we've been asked to find the derivative of this. Now again, you could multiply these two. That's going to be a lot of trouble. So instead we're going to use the product rule. Okay? Product rule. And we use the product rule a lot more later in calculus when you know some other derivatives. But right now, for an introduction to this, this is how we use it. Okay? So, again, we're going to label our functions. This will be f, and this will be g. Right? F and g. And I'm always going to write my rule, f prime g plus f g prime. Okay? Cool. Find his derivative. Well, 3 times 5 is 15. Reduce him by 1. You get 15x to the 4th. And then 7 times 2 is 14. Reduce him by 1. you get 14x. That is f prime. Now we got to write g, copy. Okay, so it's just literally copy this. X to the fourth minus 3x squared plus 11. Okay, plus, and we're going to come down here. F is literally just copy that. 3x to the fifth plus 7x squared times, and then g prime. And g prime, right, 4 times 1. Reduce that by 1, so you get x cubed. 3 times 2 will be minus 6. Reduce that by 1, so you get x to the first. And the derivative of a constant is 0. So we stop there. And someone's always going to say to me, do you have to write the 1? Nah, you can if you choose to. You don't have to, okay? And so that would be our derivative at this early stage in a calculus class. In one of my later videos, this is going to come up again, and I'll show you how you use it when you know some more derivatives. So if you have questions about the product rule, leave them in the comments, and I hope it helps somebody.